Go. Hello friends in the web section. We're going to record this lecture so that you guys can see what's going on for this new material. Alright, so this week we're going to start off about talking about collaborative programming, and then we're going to move on to basic HTML. Now let's talk about what on earth collaborative programming means, because that's a scary term when you're in an environment where plagiarism results in a failing grade. Collaborative programming refers to programming specifically in a group, and there's going to be times in most of your career where you'll be working on a group, in a team, part of a larger organization, and there's even going to be times in this class now, with the final project coming, where you'll be programming for a great deal of time in your own groups. Now, while we're covering how to program collaboratively today, that doesn't mean that your labs are going to be collaborative. That just means that we're kind of preparing for the final project. So, oftentimes before learning about version control and stuff like ticket management, people divvy up work by kind of just emailing back their code to each other, which is not particularly wrong, but it makes it hard to sync up. Sometimes I've seen groups kind of put code on a Dropbox shared folder and they all work on it, which is great, but really they're not ideal because that's not really an environment that's set up for development, for easy development. So part of learning to code collaboratively is really just learning about the tools that are available. So we're going to take a look at something called version control software, ticketing systems, and then we'll discuss what's known as a very basic workflow in order to distribute our work amongst our team members, ourselves, and these skills are going to be very heavily applied when if you decide to become a career programmer, which I would assume most of us are, being in computer science. Because most of these things that we see today, we're going to see for the rest of our lives, just as we go through in the industry. The most important thing you can learn from just anything that we're going to cover for probably the next half hour or so is version control. So who here has ever said, oh, I have to go back to something I just wrote before, I'm going to Control Z and hope that I see the thing that I want to see? Where you're going through your code and you're like, oh, it just worked a few minutes ago. I saved it. Let me Control Z, find it when it worked, and then continue, because the code I just wrote just isn't working out too well. Well, I am the absolute master of doing that. I have Control Z'd my way through things. I've Control Z'd too far back. I've Control Z'd trying to get somewhere where it's just long lost to history of however the program works, and it's been a source of pain. Also, what happens when my computer resets? I can't exactly Control Z then. I have to kind of guess what previous, Phil in the past was thinking and try and go back that way. A version control is a kind of a general term for all these sort of technologies that solve that problem by allowing you to keep a history of your files. Now, it doesn't have to be code files, but let's be honest, 99.9% of people using version control are probably us developers. It allows you to keep track of a history of your files. It also allows you to do some other cool stuff depending on what version control software you're using. And we'll talk a little bit about that stuff as we go through the lecture. Now, the most important thing is that it also allows you to go back in time. Not really, that would be pretty cool, but it allows you to retrieve the code that you write as it was in the past. So if I if I update my files and I've ever made a snapshot of my code at a point in time, and then later on I make a bug, I want to kind of wipe out my changes and go back, with just a few commands I can change a file to go back to the way it was when it was working. Now, it's very important to use version control when working collaboratively, simply because it's one of the easiest ways to synchronize all your changes. It's also just when you start developing in a feature developed manner, it's just a lot easier to use one of these. That way you can work on one feature, you can make changes, isolate those changes, but then go work on another feature, and we'll explain why it's going to be so much easier when we use version control. So, because it's 2017 and it's not 1995, we're going to be using a program called Git to use our version control. Now, how many people here have heard of Git? Every term it gets to be more and more people. It's great. How many people have used Git? Okay, about 5 or 6 of you. That's good. That's a good spread. So Git is right now, I would say, arguably the most popular and widely used version control system and that might not even be arguable. It might just be accepted fact at this point. I'd have to check. It's used personally, it's used professionally, it's used hugely in the open source world, it's used in the industry for enterprise level solutions. It's absolutely everywhere. Now originally, just for some context, Git was created by a really important person in the world of programming named Linus Torvalds. Now does that name ring a bell to anybody? It should be very familiar. Now, does anybody know what the Linux operating system is? The dude who made Git is the dude who made the darn Linux operating system kernel. So he's really important to our world as developers. You know, if you ever load up Ubuntu, you can thank him for creating the whole Linux, well, for starting up the whole Linux kernel project. He's a really good, developer. And he created this simply to solve the fact that he didn't like the current version control softwares out there. And I've used a couple. They all work, but they're all very kludgy because they were built in a time when patterns that we have today didn't exist. We didn't really think about how to work collaboratively in the ways we do today. The most important thing you need to know about Git is that it's a distributed version control system. Now, what does the word distributed mean? It means I have a copy, you have a copy, my friend Joe has a copy, my friend Sally has a copy. Everybody's got their own copy. And we're just going to have our copies talk to each other to get changes from copy 1 to copy 2 to copy 4 to copy 3. It doesn't have to go in an order. Everybody's kind of has their own copy of everything. Now the other really big benefit about this is with it being distributed, everybody has the entire history of the repository as long as they actually request it from day one. It also allows you to kind of create a network of projects from one base project. That's kind of neither here nor there. So while you're working on one of these, if I manipulate files on my machine, I'm not affecting changes that you might be making on your machine, like we would be if we were all using a Dropbox shared folder. Now, we tend to use one centralized repository online through a software like GitHub or Bitbucket or so on, or GitLab, for the sake of synchronizing our changes and having like one central source of truth it's referred to as. But we don't actually have to. We never have to make these repositories leave our systems. We don't have to put them on the internet. They can exist on their own just on your computer, or they can exist shared amongst many computers. It really doesn't matter. It's a very flexible system. For our sake, everyone's going to make a copy of a code base, meaning we're going to start a project online, or you'll start your projects online, and you'll just pull down a reference to that and clone all the data from it and keep yourselves in sync for your final projects. So first and foremost, Git is a command line program. There are many user interfaces for it that you can download if you kind of are into that sort of stuff, but I have always actually found the user interface is much harder to use than the actual command line for Git. So I recommend you try and use some command lines. If you need a user interface, there's plenty out there that are supposed to be very good. It might be beneficial to look into. We're going to use Git to work collaboratively. Now, the way we do that, we have a centralized repository. We all pull our references, just to reiterate. When we're done, when we make our changes, we're going to make what's called a commit, which is a snapshot, and we'll go through this all momentarily. And then we'll kind of push it up to that main server. We'll go through what a code review is, and that will allow team members to pull down the changes that you write on your computer. You're going to push them up to the central compute repository. We'll use GitHub today. And then it allows team members to pull down that data and just kind of pull down all your changes. Now, before we even get into actually doing the Git process, we should talk about how you distribute work in general, though. So, from what I've seen and from what I've researched, happens to be a lot on this topic, it's easier to talk about doing work and learn about doing work than doing your work at work sometimes, is there's three general ways that people tend to split up work amongst teams. One of them is feature-based. Now, who here has worked on a bigger project, maybe in the workplace, maybe in a term-long project before with team members? Okay, only 2 or 3 of you. So, bigger projects tend to have this concept of what features are in this program. And academic projects don't always have this concept. It's more like you're writing a program that does X, Y, and Z. But when you're working on larger projects, you tend to be writing a program that has many, many features, and usually they're pretty self-contained. So people tend to break up their project into a set of features. Now, if we're talking about a blog, for example, One feature would be adding users. One feature would be editing users. One feature would be adding posts, editing posts, deleting posts. All of these would be different features. Now, it's very common for, for people to say, oh, we're going to split up the work based on features, and if you have that feature, if that's what your job is for now, to work on, editing users, for example, then what you're going to do is you're going to do the HTML, the CSS, the node code, the database code for that feature. It's a really good pattern, works for a lot of teams. Some teams also practice what's known as architectural ownership. Now this is when each team member takes a region of code to own. Now when I say region of code, usually we start, as we develop into more web programming patterns, you'll see that there's a whole set of code problems that you do on what's called the front end. That's what the user sees, that's what runs in their browser. And then there's the back end, that's the server stuff. And there's more and more layers than that, and you can get into, you can break these areas down into further layers. And oftentimes you'll be on a project where somebody will say, well, why don't you just write the back end code and I'll write all the front end code? Or, team member A will do, the routes, which are, kind of how to handle a request on a server. Team member B will do the database calls. Team member C will do the HTML and CSS. Team member D will do, the JavaScript or the front end, and so on. Another really popular way amongst people who are comfortable kind of working on every part of a system is the ticket-based approach of work. Now that's when you just create tickets for bugs, issues, features, and so on, and you have a giant pool of tickets. Usually they're ranked by priority or something like that, and you just kind of pick a ticket and you just work on that. Today it could be working on users. Tomorrow it could be working on navigation. Tuesday it could be working on accessibility issues. So really it's a more self-contained way, and it's better for teams that are comfortable kind of just choosing what they want to do, but know the whole system that they're working on. Often also for feature and architectural ownership-based systems, you will also be using tickets, but the ticket-based system is kind of more for when you just have a general ton of work to do. Now, ticketing systems have evolved. They used to be on a whiteboard where, project manager man would write, or woman would write, a bunch of tickets on the board, lists of things that you have to do. They come in the form of clipboards, and they come in the form of just any sort of list thing people have done. Nowadays, ticketing is such a common thing that there's a bunch and a bunch and a bunch more than a bunch ticketing systems available online for you to use. I think I included only free ones on this list. I might have Mingle, I don't remember if that one's free actually. But here are some popular ticketing management systems. I've used most of these. Asana is a simple listing thing. It allows you to say, oh, here's a kind of like a milestone to achieve, so that would be something like building out the front end. Make a bunch of tickets for this kind of collection of things. And each ticket, you can just put a title. It's like a to-do list, a title, a description, and somebody that is supposed to do it. Trello is quite literally a giant to-do list application. If you've never used it, it's great for academic organization too, I found out in college. It makes it really easy to just make what's called a board, which is going to kind of like a group of related tickets, and you can kind of define your own workflow and drag tickets from one section to another as you go through them. It's a really fancy to-do list basically. Now directly on GitHub, a website that we might be somewhat familiar with by now, you can actually manage issues on that directly, pretty easy. Mingle is another growingly popular project management software right now, and Waffle, great name, uses GitHub issues to create a project management setup board. So all of these are very, very common, very popular ticketing management systems, and for your final projects, or for your group projects in general, or for your life in general, you might find any and all of these pretty useful for managing and organizing your tickets and your features and so on and so forth. So now that we know in a general sense of how to organize our work, how do we do that? We're going to use Git, and we're going to talk about how to use Git to accomplish this. First, we're going to go over some terms, though, about Git. Now, before I mention having your own copy of your project, or whatever I might have said, code base or project, with its entire history, the term for that is your repository. So, we're going to put a repository on a website known as GitHub. You're all going to clone that repository and have a local copy of the repository on your computers. Now that's going to be all the information about the files, the folders, the structure, the history of them. All of that contained together is the repository. We're also going to talk about a branch. Now Git is like a giant, kind of messy tree where you can have a set of changes and they all follow kind of a time-based history, but then person A and person B can both say, hey, we're going to work on a feature now, and they'll say, let's make a new version of our history starting right now where we both kind of branch off and work on our own path of history for a while, and then we'll bring it back down into the main branch that we work on. So a branch is kind of like this chain of file histories, and they can be pushed up to the remote repository, and when you work on one branch, you're not affecting other branches, so it's very easy to contain your code in an isolated fashion. Perhaps the most important thing about Git is the commit. The commit is your snapshot of your code and file structure and everything about your repository at a set point in time. So when I make a change, I commit that change, and when I make that commit, there's now a permanent record, unless I delete the repository, of what that code looked like at the time that I made that commit. Now, the remote just refers to a reference to another repository, like a copy of that repository or something like that. In our case, a remote is the GitHub repository we'll be using. There's the act of pushing, which is taking commits from your computer and sending them to a repository online. There's the act of pulling, which is taking commits from another repository and pulling them down into your repository. A merging is the act of having commits from another repository or another branch pulled into wherever you're working now. And a pull request is something that you're going to make on GitHub or whatever you use that makes a request to bring your series of changes into a particular branch. Now this is where you do something really cool called code review. Code review is a really nifty practice for trying to make sure that you follow a good pattern for your team, follow internal styling and stuff like that, and avoid a ton of bugs by reviewing each other's code. So we're going to start off by making a repository on GitHub. I should have included step 0 basically. If you're going to use GitHub or Bitbucket or whatnot, all these are just free websites where you can sign up for free, naturally if they're free websites, where you make your own account and you can make new repositories and store them online. Now, for the sake of this course, you don't have to really pay for anything. Your final projects are all going to be unique projects, so it doesn't really do you any wrong to have your projects be public. So all free repositories on GitHub are public. Yes, I had to double check the way I said that for a second. Sorry about that. All the repositories you'll be making for free will be public. Now you might be able to use your Stevens email address to get free private repositories, but you don't really need to if you don't want to. So we're going to go through making a repository, and we're going to I'm going to basically pretend to fill that out because I already we'll show you how to make a new one. So I included a link to the page to make a new repository, and last night I happened to make this, as you can see here. I made a new repository for us called CS546 repo example, which should be included if you go to the lecture slides and click on this link, which is not working on the PDF, is it? I'll have to investigate that. I'll provide a link momentarily. That's so weird. Well, the link to it could be found on my page. For now, we'll just pretend. Let me just get that link. No. Just open it up. There we go. So I'm just going to get that link ready. So anyway, back to the make a new repository page. So when you make a repository, you need only one thing, a repository name, but I recommend that you have a couple more than these one things. So the first thing we need, I'm just going to add a -2 so that I don't overwrite my old repository. The first thing you need is a repository name so that you can actually set up this project. And then a description works really well. Now, a description is just kind of shows up on GitHub for you. Now, I recommend that you select this, initialize this repository with a README file. It'll pull the contents of your description. And I also recommend that you click this button that says add.gitignore. Now a gitignore is a list of files that are not included in your repository history. And I recommend you type in and click the node one. That way you don't commit your node modules folder. It'll be ignored from your history. That's one of the reasons why package.json is so important. When we work together, we share our package.json file, but we don't share our node modules folder. That's because if I'm on Windows and you're on Mac, for example, I will have slightly different node modules when they're compiled node modules. Also, node modules, if you've ever looked into the directory, it's huge. If you have a node project, 99% of the size of your project comes from the node modules folder. So we don't want to share that. I tend to put the MIT license on basically every single thing that I build. I made this decision like several years ago, and I just found that to be the most kind of all-encompassing, easy-to-use license for basically anything that I'm building, which really doesn't matter in the term of licensing, but don't worry about licensing. So you create that repository, and now online you'll have this history, you'll have this whole repository set up. Now it exists on GitHub, but you want to work on it on your computer, I'd imagine. So you're going to go through a process called cloning the repository. Now cloning the repository involves you using Git, and if you haven't downloaded Git, I recommend that today you go through the slides, and you go to, where is it? Well, I include a link on the over here on the How Can We Use Git slide. And that link will take you to the download for your operating system. And now Git is a command line program. So if we want to use it, we have to run commands. Now the command to clone a repository, or rather to clone a copy of to make a copy of the repository, known as a clone, is to take this URL that GitHub gives you when we have this clone or download button, and to type in git clone, and then just paste that URL in there. And now it's going to download everything. It's going to download all the history for the master branch and put it in this directory called CS546 repo example 2. Now if I type an ls command, you can see it has exactly what's up here. Doesn't really have anything else to it. And now we can make our changes. So say I wanted to update the README. I might say, oh, this is just a basic text editor. Added text. Now, the beautiful thing is, nothing I did changed the online code base just now. It seems kind of trivial to mention that, I know, but I'm trying to really stress the fact that my copy is mine. Nothing I do on my copy affects anybody else's copy until we all start interacting with each other more directly. So we're going to take a look at how we would do that. Now, so I just made a change to the readme.md file. Now, MD stands for Markdown. It's a really simple language used in writing all sorts of little documents. And so I want to say I come back to this in an hour and say, oh, what was I doing? There's a command in Git to say, what was I doing? What is the status of everything that's been changed since my last commit, my last snapshot of my code? Now this git status command will show things that are ready to be staged, which will go into staging, and will show us things that are staged. So really what it's showing us is, of everything, what changed since my last commit? You're going to use this git status a bunch of times. Now, if I added a new file, say nano readme-2.md for some reason, and I said this is a test, and I did a git status, you'd notice that it's called an untracked file. An untracked file is a file that's never been in your Git history. Now you have to manually add it so that Git knows, hey, add this file, start tracking it in our history. So I can do git add readme.md to add the changes I just made to the original readme, and then I can do git add readme-2.md to add that new file, and then I would make what's known as a commit. Now a commit is the snapshot of the code at a point in time, and only changes that we've added, which is termed staging, it's because you're staging these changes, these files to be committed, will be added into this commit. So if I also did nano test.txt. Hello. So you see here we have one untracked file and two changes to be committed, two staged files. And I did a git commit -m for git commit with this message, test. I'll just do that. And I did a git status again. You'd see that I still have that untracked file. It wasn't snapshotted, but the other two files, they went away because now their changes have been committed. If I do a git log, I'd see that there's now a new entry called test in my commit history. It's a brief description of what I just did. A really bad description. You shouldn't name commit something like test. You should probably say added readme to or something like that, and so on. But that changed. The test.txt didn't appear. But still, even though I committed, nothing came up here. So let's talk about pushing up our changes. So in order to get these changes up on the main repository so that all my friends can see all my code and pull their changes down, we have to push our code up. Now, the command to push is really easy. It's git push. Now you have to specify two other things with the git push command. The first is the repository that you're pushing to. Now when you clone, it automatically adds a reference to a repository called origin. Origin is wherever you cloned from. So in our case, git push origin is saying, hey Git, remember that GitHub repository that you cloned from? Well, why don't you go push up to that repository? Now, this will only work if you actually have access to that repository. You can't push to my repositories, for example, but you can issue a pull request, and I'll just kind of go through that in general, so that you can get your changes merged in. So you would do git push origin master to say, hey Git, push up to the origin repository and push my changes up to the master branch. Master is the original branch. It's usually the one that's supposed to be the best clean code, the working code, and so on. It's supposed to be the epitome of your code base. So by saying git push origin master, I'm saying git push my local branch up to the origin repository's master branch. And now I have two commits, as you can see here. We've got a new file, readme-2.md, and we have that new commit message over here, test and test. Now, say that somebody else made changes. I would have to pull down their changes. So, just to kind of emulate this, I'm going to make a third change from I'm going to reclone the repository in a different folder, and I'm going to make a change, push it up, and pull it on the other copy of the repository. Now you can have, because it's distributed, I can clone a million different copies of this repository on my hard drive as long as I have space for it. So say I'm going to go to my desktop, make dir temp. Well, I'm going to just do git clone, then the URL, but then I'm going to add a parameter to say what folder. We'll say fake other person. Then I go into there, and then I'm going to say nano readme2-md. This is a test, this is another test. Now as you see here, even though I'm on the same computer, when I'm in window number 4 over here, I have this change recorded of readme2. When I'm on window number 3 over here, I don't have that change because each repository is its own self-contained copy of the code base. So now I'm going to git add readme2-md, and I'm going to say git commit -m, emulating second person coding on this repository. And then I'm going to push up. Awesome, it's pushed up. Now I'm going to refresh the page. Alright, it's actually up. And so now I'm going to say, hey, I want to pull down all those changes, and you can use this fetch command to see if there are changes. And you'll see here if you fetch, you don't need to fetch very often, only if you really kind of want to get down information about the repository. You'll see it says, oh, you're behind. So you can do git pull origin master to say, hey, I want to pull down that history. I'm at currently these two commits. I want to get whatever commit I'm behind. So I do git pull origin master. And that says, hey Git, pull the changes from the origin repository branch master onto whatever branch I'm in right now. Now if I do a git log, I have a copy of their history as well. Now you could imagine if I was two different people doing that, that would be how we would share code. Now that could get a little messy, because if we're all coding on this master branch, we're going to create what's called a merge conflict at some point. Yes? So cloning is kind of like a pull of everything, a fresh copy of the repository in general, whereas pulling is just pulling down changes that have occurred since the last time you pulled. So you clone the entire repository, but you pull down into your repository. Now, the reason why that's particularly useful is because on my repository, I might be making a couple of branches, for example, to work on 5 features at once. And I don't want to lose those, so if I clone and I don't have those pushed up to the remote repository, I would lose those. Also, because cloning has to get all the history, it takes a while to clone a large project. So, let's pretend we wanted to make that update to the README. But let's pretend we're making we shouldn't even pretend. What we're going to do is we'll actually do the HTML section of this website, of this lecture, using Git as well. But we're going to talk about our workflow first. Now, workflow is a pretty generic term that really means how are we going to proceed with something. Cooking has a workflow, every recipe has a workflow, every person has a workflow for how they get through their day. When we talk about workflows in technology, in programming, we tend to be talking about how to approach a ticket, an issue, something like that. So one of the most common paradigms we do is by using these branches to kind of work on our own areas. Now, just to give an overview of how I should have changed that file in an ideal world, was I should have made a new branch devoted to all the changes I was about to do. And I would do that with the git checkout-b command. Now I will show this to you all as we write the HTML in a little bit. And I would make a branch, maybe named feature slash, index, feature slash, about me, feature slash coffee HTML, because invariably I always go back to writing about coffee. Then I would make my updates. I might have 1 commit, I might have 20 commits. I would just keep committing, and every time I commit, I would push up my branch to the remote branch so that it's all up to date, so that if my computer crashes, if something like that happens, that it's up somewhere so that I can just reclone it from another computer when my MacBook might, maybe the RAM blows out or something, or my hard drive gets magnetized. And then when this feature is done, I would issue what's called a pull request. A pull request is just a kind of a way of saying, oh, show somebody all the differences in my branch, and if it can be merged into the branch that I want it to, allow them to merge that code in. And you'll see this all as we go through the HTML. And then it would be merged. Now that's a really common workflow. It's a simplified version of what's known as Git flow, and we'll do these demonstrations just by virtue of doing the rest of the lecture. It's a really simplified way of doing what's called the Git flow workflow. Now, Git flow is has a couple more steps than that, but for the sake of our course, we don't really need to get too much into that. Not everybody uses that workflow. Everyone has their own internal philosophy. There's a bunch you can look up. Git workflow is an interesting topic to research. Now, before we continue, we really have to take a minute to say, but what issues are going to occur here? Now, when many people edit the same files at the same time, sooner or later, they're going to edit them in such a way that Git can't figure out how to rectify the fact that I changed it and that the programmer next to me, Joe, changed it. Because we might change the same exact line 2 different ways. So when Git encounters one of these situations where maybe Joe pushes to the master branch, I pull from the master branch, but we've both committed changes to the same file, you're going to get something called a merge error. Now these merge errors, the only way to resolve them is to simply look at the code, look at the merge error when they occur, and figure out what's the real version of the code you should be using at this point. A bit labor intensive when they're large. So we can avoid a lot of issues by just doing a few common tricks. One of them is, that how before I said our master branch is that main branch, it should be our best code? The easiest thing you can do to make sure to minimize the amount of issues that you have is to never actually develop on your master branch. That kind of slows down the pace of things hitting the master branch. Instead, what you do is you make a second branch. Maybe it's called, well, for every feature that you make or for every bug that you fix, you make a new branch. And we'll see how to do that today. And when you're done with that code, then you put up a pull request for somebody to go through code review. Conversely, as things get into master, pull it into your feature branch. Keep your feature branch as up to date as humanly possible. Because if you're already up to date and there haven't been any merge conflicts, now next time you edit your code, you'll be editing it at a later point in time, so there won't be any conflicts because Git will see this kind of linear pattern of history, like, oh, 3 hours ago, Joe edited the file index.html. Now, 2 hours ago, Phil pulled that change into his branch where he did not yet edit index.html, and then now Phil's running the most up-to-date version of index.html. 1 hour ago, Philip committed a change to index.html, and that's okay because his changes came linearly after Joe's, and he merged Joe's code in before he started working on his own code. That avoids, right there, most of the merge issues you'll ever occur. The other thing, much like making modules everywhere in Node, you want to isolate your work into really small chunks. The smaller the work that you can do, the better it is. Make sure it's all self-contained as possible. Your new feature branches should start off with master. Now, even if you're making a feature for, say, or fixing a bug for something like, let's just go back to blogs, adding blog posts or editing blog posts. Now, say you want to make a new branch that, say you now are going to work on a feature for editing users. You want to actually go back to master first and then start branch again to edit users, because those two code bases shouldn't really have anything to do with each other. You should just kind of hope that, in cases where you start one feature like editing blog posts and then you have to start another feature that relies directly on that code, that's when you branch off of that branch. You're not going to really need to do that for this course very much, I'd imagine. That's more when you start kind of really different types of development styles. And finally, once again, pull often. I can't describe how important it is. Stay as up-to-date with the remote branches, remote repository as you can. That just makes your whole life a lot easier. Now, any questions about Git in general? We're going to see it a lot more as I go through the lecture today. Alright, I've included 2 references. One's to a general guide, and one's to the actual Git website guide. So, finally, let's talk about HTML, which is the fundamentals of everything we're going to do for the rest of the course. Who here has ever written a line of HTML before? With so many hands, I just have to wonder what I can teach you all. Alright, so we're all generally familiar with HTML. But let's go into it in a kind of ground up, pretend we know nothing sort of fashion so that we can learn why we write HTML the way we do, not just how to write HTML. So HTML stands for the Hypertext Markup Language. It's a way of describing content. It doesn't have anything to do with how things look. It doesn't have anything to do with web pages. Or it has a lot to do with web pages, but fundamentally, you don't need a browser to read an HTML document. If your HTML document is formatted in a really what's known as semantical way, you can take a look at it and know exactly what the page is about. HTML is a language to just mark up content, meaning it describes the content with a bunch of tags saying, oh, this sort of content is navigational related, this is an anchor to other content, and so on. Now this week, we don't yet have servers. We won't be making a server this week. Instead, we're just going to work on our local machines using one of our brand new GitHub repositories. Now, HTML isn't anything special. It's really just a text document that happens to be formatted following the HTML standard. And HTML is written as a series of tags to describe your content. Technically, it describes a web page. Now, it's not a website, it's not actually a web page, but it describes content that you'd put on a web page. Your browser is where the magic actually happens because it interprets the HTML And then it says, oh, let me generate a page from this HTML. Let me show the user it in a way using some styles that I think make sense for the user to see. Later on, we'll get into CSS, which is how we style HTML. But for now, all we're going to care about today is the content of our web page. Now, an HTML document it's pretty simple. It's a series of tags. Now, an open tag has attributes on each element, but rather, let me just go back 2 seconds. HTML is a series of elements, sorry. An element, you can view each element as kind of a part of a tree, because an HTML document is kind of like a whole tree of elements, where you have elements inside of elements, and they can have many elements inside of those, and so on and so forth. There's this concept of parents, children, siblings, and so on. It's kind of like an n tree, where you can have n number of nodes per leaf in your tree. Now, each element is composed of an open tag with some attributes and properties, and elements inside of that. Now, there's a couple of really important elements that we'll see: the HTML doc type, the HTML element, the head element, the body element, and so on. And you can add a unique identifier to each element. It's unique for that particular document. So if page 1 has an element with an ID of navigation, your second page could have an element with an ID of navigation, but it can't appear twice on the same page. And they're described in the document that you write, and they're rendered by what's known as the DOM. We'll go into the DOM and how browsers actually work a little later on in the course. But for now, let's take a look at what I just said. This is the most basic HTML document that you'll ever see, because it's the bare minimum needed to make a valid HTML document. It's a doc type, which is just what type of HTML are we writing. In our case, we're writing HTML5. You will probably never write HTML4 again. No one knows when HTML6 will become a thing. So we just have HTML5 for now. That's what we do. The HTML5 document type is just this one line. They used to be very long. Now they are not. The next tag is the one that's going to have the actual children of it. Everything in your document is inside of this HTML tag, element rather. And a tag is what I just highlighted. It's an open tag. Well, an element is an open tag, a closed tag, properties and attributes, which look like this, and then the children elements inside of it. So HTML has an open tag, HTML has a closing tag, and the HTML element, rather, has an open and closing tag, and it has these children inside of it. Now, the children are elements. Head is an element describing data about your data. It's your metadata, it's your page title, it's your favicon, it's references to CSS style sheets, and so on and so forth. This line about charset just tells the browser what sort of text you're using. Titles are very important. Your document has to have a title. Body, everything you see on a web page comes from the body. All the HTML that we write is going to be inside of the, let me rephrase that. All the visible HTML we write is going to be inside of the body element. Now, the body is just another series of tags, open tag, close tag. Here we have a comment. You can see it all here marked up and it's formatted. I'm using Visual Studio Code. It's really good for HTML editing. It's a really pretty editor. And so the screenshot on the left is just the stuff on the right, but through an editor that kind of shows how it's formatted and color coded for easy reading. So, any questions on kind of what an element is? All right, excellent. Now, this week we're going to go through using that repository and create a meaningful document about different types of coffee, because that is one of the only topics that I can just stand in front of a room about and just keep talking about. So, we're going to talk about different types of coffee, maybe how to make them, something like that. And we're going to use this to learn about formatting text, organizing our data, making lists, and potentially some tabular data if time permits. Let's see what time it is. Time might permit, I'm not 100% sure. So, before we even start writing, here's something that I'm going to need to kind of discuss about writing HTML. Everything you do in web programming, you need to think in terms of reusability, because you're going to now suddenly realize that 99.9% of the front-end code you'll ever write, front-end is HTML, CSS, and JavaScript on the browser, is reusable. You're going to be following design patterns. You're going to be making the same type of elements with the same type of elements inside of them over and over and over again. So you really need to think in terms of making your sites and your content as reusable as possible. Now, you'll see what this means as we practice what's called semantic documents. And semantic documents just mean the elements that we use really describe what the content is. And we'll see what that means as we go writing our stuff. So we're going to make we're going to focus on reusable patterns in our HTML. We're going to think of things as generically as possible. Now, also before we start writing HTML, there's another thing that you have to know. Your browser is only a little part of what HTML is used for. Has anyone ever heard of a search engine? A pretty important thing for our modern world. Google, biggest search engine in the world, has to read all your HTML, and it has to say, oh, using what I know about HTML rules, what is their page actually about? What's the actual content of the page? So the more valid and semantical your content is, your actual HTML document, the easier it is for a search engine or another sort of scraper. There's tons of programs that just read your website and do something with the content. The easier it is for those sorts of programs to understand and use your website data, successfully. More importantly than that, arguably, is accessibility tools such as screen readers. Now, we live in a really good time for web development because it's starting to become a much more accessible field. Accessibility refers to the concept that your website can be used by people that can't necessarily see the content or digest the content in the same way that maybe somebody like I could. And what that means is, for example, without my contacts in, I can't really see a screen. I have very, very, very poor vision. Now, say one day, hopefully not, hopefully I can get, hopefully modern medicine avoids this situation. One day, I may no longer be able to see. But because we have this accessibility movement, by the time that may or may not happen, getting a little worried up here thinking about the inevitability of the future here, there's all sorts of tactics and there's all sorts of programs that can read an HTML document and figure out how to vocalize it to me in a way that I can digest the content. So while right now I can see the screen and the content as I program it, one day I might need an accessibility tool that will kind of describe the content to me in a way that I can digest audibly. Or maybe neural implants will happen and we'll avoid the issue altogether, but we're not really sure what the future holds there. Now, there are many accessibility issues that we're going to care about in this class. Color contrast is a huge one, and we'll get into more of these as the class goes on. But we can leverage a bunch of HTML's native attributes and strengths just to make these really accessible websites. And we make our content as semantical as possible so that these assistive tools can really help people with accessibility needs use the web in an easy-to-use fashion, even if they can't really digest the content the way that we would digest it. Now, some just basic principles of this. When we write forms, we label our inputs. When we write a heading, we use proper headings to describe our content. It's really easy stuff. It's easy for us to do. It takes 20 seconds to add all these things in, and it might save somebody 20 minutes trying to read our content. And finally, never think in terms of how do I want my page to look when you're writing the HTML. Your HTML should describe what the content is. It shouldn't describe how it looks. Now we'll see a tag today. It's going to be called the heading 1 tag, shortened to H1. The H1 tag is going to, by default in most browsers, be really big text. It's going to be huge. Now you might think, well, I want big text, so I'm going to use an H1 tag. Well, not really. You should use an H1 element when the content that you're writing inside of it is the top level, most important heading for the page. It would be a title of a report you're submitting for a class. It would be the equivalent of the title of a book. It would be the newspaper article's title. Wow, it's always title, isn't it? It would be that sort of thing. Whereas the second heading, an H2, should be used not because it's a little smaller than H1 but bigger than H3. It should be used because maybe it's an author's name or maybe it's the subtitle to a piece of work. If we were describing the screenplay for a movie, Star Wars would be the H1. A New Hope would be the H2, potentially, and so on and so forth. So we don't care about style. We think in terms of our content, makes it easier to style in the long run. So let's, now that we have those kind of rules down, let's start using Git to kind of make our first HTML file. Now I'm going to go all the way up to here and shamelessly copy my own code. And we're going to open up Visual Studio Code. Now here, I am opened up to the CS546 repo example repository. So I'm going to navigate to there. Actually, let me just change the URL. Take out the -2. Now, let me exit this window. Exit this one. Wow, I had a lot open, sorry. Now I'm going to go back to my desktop, and I'm just going to quickly remove those other repositories that we're not using. No. Now we'll remove that fake other person because we're not going to need to use that at this point. Alright, so now I'm going to navigate into my CS546 repo example, and I'm going to say, alright, am I up to date? So I'm going to do a fetch, which is just a git fetch a --all. Now I'm on master locally. You can see that because it says this when I type in git status. I'm all up to date with my master branch online. So I now want to create a feature. That feature is going to be an index.html file talking about coffee. So I'm going to say, well, this is a set of changes. They should be very isolated. They don't, and I shouldn't ever develop on the master branch. So what I'm going to do, and can you all see this kind of in the back? Hopefully everybody on the recording can see this as well. I'm going to type in the git checkout command. Now the git checkout changes the branch that you're on. It allows you to go from master to another branch, and so on and so forth. And it just jumps to, makes your files be what they are in that particular branch, and allows you to work on that particular branch. Now, because I don't have a branch yet for my coffee stuff, I'm going to make a new branch by typing -b as my command, as part of my command flags. So it's going to be git checkout -b feature slash, well, let's just do feature slash coffee. And now we switch to a new branch named feature-coffee. So if I do a git status, you see nothing to do yet, but it shows me on branch feature/coffee. Now I'm going to put Visual Studio Code on its own window over here. I'm just going to move this over here. Copy this. And now I'm going to make an index.html file. And I'm going to just include the bare bones page. I'm going to just have Visual Studio format it. Now I'm going to say, alright, made an index.html file. That's enough for this commit. What I just wanted to do is I wanted to get this file up and started so that I can have a history started. Now that's just a clean version of an HTML file, has nothing really in it. So I'm going to add it. I'm going to check my status because I check incessantly even though nothing changes. Literally nothing could have changed between the time I hit git add and that, but let's just force a habit. Then I'm going to say git commit -m created index.html file. I'm going to describe what I just did. I like to work in really small commits, really small chunks of work. So now, just clearing that window, you see all these things that were on the master branch, all that history is still here, and now I have my new commit. So now I'm going to go to Visual Studio, and I'm going to take a look. There we go. Is that visible in the back? Okay. So now what I'm going to do is say, alright, what is my document going to be about? I'm going to start from the top, and I'm going to work in the head for a while. My document is going to be about coffee. Now, I have off the top of my head 5 or 6 different ways at home that I like to make coffee. So we're going to make our document about ways to make coffee. Alright, and now we're going to say, I want to make sure that whatever I just did shows up in the title of my page. So to open up an HTML document on your desktop, when it's just a local small file, You don't need a server, you just need to double click this and it opens up in your browser. It's just a plain old text document. Now you'll notice I have absolutely nothing in it right now. It's a blank white page, but way up there, ways to make coffee appears. That text comes from the title element. So if I change that to 3 ways to make coffee, refresh the page. You always have to refresh to see your changes. You now see it says 3 ways to make coffee. Excellent. Now that's a pretty useless web page right there. I really haven't made enough changes yet, so I don't want to commit just yet. I don't want to be that guy who commits every other line of code. I want to kind of get a little bit more of my structure up. There we go. Let's just get down here. So I'm going to want to say, well, what's my page about in a really general sense? My page is about ways to make coffee, ways I make coffee. Now, my page, that's what this page is about. So I'm going to use an H1 tag. That's going to be a heading. It's the highest level heading there can be. Generally, you tend to only have one H1 tag per document because your document should really only be about one thing. So now I'm going to refresh the page, and now we have this really big text show up, ways I make coffee. Now, I'm going to say the first way that I make coffee every day is it's in a tool, a coffee maker called a Chemex. Has anybody heard of a Chemex before? One day I'll have somebody who knows it off the top of their head. One day. All right, a Chemex is a glass, kind of looks like a vase that you put a filter on top of. You put coffee grinds in it, then you put hot water on that, and it runs the grinds through a paper filter. It makes a really smooth cup of coffee. Now I'm going to describe that in my document. Now I'm using an H2 tag because while the document isn't about that, I'm going to have a whole group of content that's going to be described that is going to kind of fall under this description of what a Chemex does. And you'll notice here today we're not focusing about look and feel. Everything's going to be plain text on a on a white background. It's going to be like that. So right now I'm already faced with my first major dilemma. If I'm going to have Chemex and if I'm going to have AeroPress, how is my document going to know what I write about each of them? How is it going to know, like this paragraph, which is the P tag, is going to be describing the Chemex, whereas this one is going to be describing the AeroPress? Because just because the paragraph tag happens to be underneath the Chemex element doesn't mean that it necessarily would be describing that. Well, this paragraph could be describing the entire page. It could be describing anything, who knows what it's attached to. We don't really, because it's just in the body tag, as far as your browser is concerned, as far as screen readers are concerned, the only thing that this paragraph tag describes is the body, because that's what it's directly inside of. So we immediately have this need for separating our code into different chunks. And we based on the content of the actual thing, of the actual document. Now we're going to add some tags here that just describe the content itself. They won't have any visual impact at all, but they really help us lay down this fundamental structure of what our document's about, what our content is about. Now the first one of these that we're going to see is going to be the main tag. Now the main tag describes the main content of your page. In our case, we don't have any content yet that's not going to be inside of the main tag, because all of this is directly relevant to the page itself. Now I could include some data that's not really associated to the content of the page, that would be associated with maybe the site, and I'll put that in a tag called the footer tag. And this site, and copy. Now I'm going to say in my footer, this page, copyrighted by Phil Barisi. The way you do a copyright symbol is this notation. It's when you need to write a fancy character, you'll look up trademark symbol HTML, copyright symbol HTML, and it'll tell you how to do it. So here now we start to see this organization of our page. But yet I could take out the main tag, and I could take out the footer tag, and the visual aspect of it wouldn't change. But now with those tags, we're starting to see a more kind of semantical organization about what our content is kind of come up. Now, We're better, but we're not yet good enough in terms of organizing our content, because our paragraphs are now just describing the main thing. Our headings are now describing just the main area. So we have two options. One of them is to make what's called an article, and one of them is to make what's called a section. Now in our case, articles and section, well, in all cases, articles and sections are ways to divide your content, much like the main tag. Now we're going to use the article tag because each thing we are writing inside of each article tag is going to be a self-contained article of content. Now, hold on a second. Article is kind of a misleading term at first glance. You might say, well, I'm not writing news, so why am I writing an article? But article specifically refers to a self-contained article of content. Now, what's an article of content? If we're writing a website that has comments on it, every comment would be its own article. If we're writing a website that has a bunch of different social media posts, every individual self-contained social media post would be an article. If we're making an Instagram clone that shows, the picture with a caption. I don't know. Does Instagram show a caption? Sure, we'll go with that. It would be, the article would contain the picture, the caption, how many people liked it, or whatever people do on Instagram. And so it's about having a self-contained area of content. Now we would use sections to describe bigger sections of the content, like maybe comments would all be contained inside of a section, while the main article would be contained inside of the section there, and so on, stuff like that. That's how we would organize. And now we've created, without changing the look and feel of it at all, we now have this organization of, well, we've got a body, and inside the body, this is the content of the document. The main content is going to be about ways that I make coffee. And I'm going to have this first way, it's a self-contained group of information that's going to describe how I make coffee in a Chemex. The second one is going to make a description of how I make coffee in an AeroPress. And then I'm going to add another one that's going to be about the Hario V60. And I'm just going to say describing Hario V60. And now I'm going to say, you know what? I am really happy with that amount of work. I want to commit that much. Because now I have something substantial. I have a kind of skeleton layout for my content. I know what I'm going to talk about. It's ready to make a commit again. So I'm still on my branch. And I'm going to say git commit. Oh, I'm going to do git add index.html. I'm going to do git status just to verify. Awesome. It shows that it's changed to be committed now. And I'm going to do git commit -m added skeleton of content up for coffee descriptions. Git push. Now I'm going to push it, and instead of pushing it to origin master, I'm going to push it to feature/coffee. Now, before I do that, we're going to see on here, let's take a look at these branches. Branches are lists of kind of self-contained areas of history, and right now we don't have any. So I'm going to push to the origin repository branch feature/coffee. Now it says new branch because we just created it online as well. And now we refresh the page, and it shows up under under active branches, and because I made it, it shows under my your branches category. So if we go here, it's now 2 commits ahead of this of master. So I'm going to keep working on that. Now what's some other interesting stuff we can do? We can emphasize, getting a little horse before the carriage here. So now it's time, the carriage before the horse. Now it's time that we start writing a little bit more about our content. We keep this kind of concept of making it semantically valid in mind. Now, I want to say, I'm going to start off with Chemex coffee, because Chemex coffee is my absolute favorite way to make coffee. So I'm going to say, making coffee in a Chemex is my strong, absolute/strong favorite way to make coffee in the world. And I'm going to enable word wrap right now. Now I'm going to go look at this, and you'll see here, now I have one word that's in bold. Now, the strong tag is used to emphasize, not used to emphasize, it's used to stress that a certain piece of text is particularly important. So I might say something like, maybe I put it as absolute favorite to kind of really make that stressed out to be important. I'm saying that this content, the term absolute favorite, is really important towards what I'm writing right now. The browser says, hey, he said this text is important. I'm going to make it bold so it jumps out visually at the user. But strong, you can't think of it as something that makes the text bold. You need to think of it as something that really stresses that a piece of text is important. Now, there's many reasons why you might do that. Say you were on a website that has a bunch of vocabulary because we're using, maybe it's a scientific article and it's going to have vocabulary that you might not be familiar with or that the article is mostly about. You would maybe write all those important vocabulary words or whatever in strong tags so that they jump out because they're what the main focus of that article is about. Now, there's another important tag that has a visual connotation to it called the EM tag, which stands for emphasis. Now, we would write using EM, it is the best way to make coffee in the world. Well, I wouldn't say that because I just wrote in the world. Best way to make coffee for yourself. I'll say I think it is the best. It is the most awesome. That's what I'll say. Way to make coffee for yourself or for a few people at once. Or for a few people at once. Now you'll see here, a little hard to see, so I'm going to zoom in the browser. The word awesome, which I put in an emphasis tag, shows up as italic. Now, once again, you can't think of the emphasis tag as something that makes italics appear, but instead, you can view it as something that that person is emphasizing. It's almost a vocal thing. So if I were reading this, I would say making coffee in a Chemex is my absolute favorite way to make coffee in the world. I think it is the most awesome way to make coffee for yourself or for a few people at once. Now you notice I emphasized awesome. That's kind of when you would use that emphasis tag. Maybe you're really emphasizing some wording, you're emphasizing a choice of wording, how you would say it. That's when you use the emphasis tag, when you just want to say it's awesome, complete with that little gesture right there. All right, we're doing good on time. Now, let's talk a little bit more about other types of text. We don't really have addresses to put up because I'm not giving my home address right now on the HTML page. But there's some other things, and you can see them as you write out documents where you'd put addresses in an ADDR tag, for example. You might just want to add different style or markup or emphasis or something special to text that's kind of specific to your website using a span tag. And you'll see this way more when we do CSS, that span tag. If you're writing an academic order, well, if you're writing anything that needs a citation, you'd use the cite tag and put that citation information inside the cite tag. And if you're quoting somebody, you would use the block quote tag. Now, this is really important to write it in this semantical manner because it really describes what each article, what each line of text you're writing is. And we actually did this. So now we're going to talk about something that you'll never realize how much there is. Lists. The funny thing about list data in HTML is that once you start using lists, you're going to realize that just about half of the information in the world is actually a list. Half of what you read online is actually a list that's just been styled to not look like a list. Most data, not most data, a lot of data that we read and digest is lists of things. What those things may be doesn't really matter. So, we're going to make a list that shows a series of steps to make each type of coffee. So I'm going to say, let's make an unordered list for the ingredients. So I will make now an H3 that says ingredients. And I'm going to, every list has list items in it. So we're going to start off just by stubbing out that structure. And now we're going to make an unordered list, and we're going to add list items using the li element, which stands for list item. Now the first ingredient you need for making Chemex coffee is coffee grinds. 30 grams, well, 28 grams, medium coarse ground. The second ingredient you need is water at 204 degrees Fahrenheit, 780 grams worth. I think I'd have those memorized. I do this every single morning. And now I might say, well, now I'm going to make a list of steps. So I'm going to say how to make it, how to make this coffee. And so I'm going to want to use, notice here, we have this bullet point. Great. The bullet point kind of visually shows us, hey, we've got a list of stuff that's, order doesn't matter. It's just a bunch of, this thing, this thing, this thing. But we want to say how to make the coffee. Well, I don't know about you, but if I tried to bake something and didn't follow the order of instructions, it would come out catastrophic. For example, try making bread where cracking the eggs over the baked product is the last step you do. That's not something you do. You need to make sure that this content says, I'm giving you a list and it's going to be ordered. So we use a tag called the OL tag instead of the UL tag. OL stands for ordered list. And that denotes that this content, the order that we put the elements in, really matters. So the first thing we're going to do is freshly grind 28 grams of coffee to a medium coarse grind. The second thing that we're going to do is boil water, heat water to be 204 degrees Fahrenheit. Heat 800 grams of water. After heating, you will have at least 780 grams. So just because I'm giving you guys actual real information here, we'll just kind of go up to 900 grams there just for some padding. Now we're going to say the next step is going to be place a paper filter into the Chemex. Next step, now all these steps matter. Use the heated water to wet the paper filter. Now notice still matters. Everything here, order matters. Discard water used to wet paper. Place grinds and filter. Pour 50. So we'll go with 75 grams of water onto the grinds in a concentric manner. Let's see. Let sit for 45 seconds. Let coffee bloom for 45 seconds. And we'll say over the course of 30 seconds, let coffee bloom for 45 seconds. Then what we do is pour 705 grams more of water over 3 minutes, 30 seconds. 3 minutes, 30 seconds in a concentric manner. Keep coffee water level 1 inch below filter top. Awesome. Now we have a recipe. Every step mattered, and the ordering of each step mattered, because it would be really weird if I put 800 grams or so of coffee in before my coffee beans went in. I wouldn't be able to make coffee. Instead, I'd be really disappointed drinking boiling hot water. So our content and how we describe it really matters. Let's talk about tabular data then. Wow, we're getting pretty far actually. Now, say I wanted to describe data in kind of a way I'd make a spreadsheet. That's when we use tabular data. Tabular data is stuff that kind of follows this general rule. When you're presenting data, if you can say, is this the sort of data that would appear as a table in a textbook or something like that, or a document? If the answer is yes, you're going to end up using a table tag. Now let's say we're going to add now a section here, and we're going to say this section is devoted to just the actual recipes. And we'll make a second section below it where we'll say this section will be about ranking coffee methods. And close off that section. And here I'm going to make a simple table that says what type of coffee and whether it's my favorite, least favorite, most favorite, medium favorite, so on and so forth. And that's the sort of data that would appear in a table. But wait, I'm getting a little ahead of myself. I should commit it. Because I have a lot done at this point, and I probably should take this out temporarily and say git add index.html and say git commit, let's commit with a message that says described Chemex coffee. And git push origin feature slash coffee. Now we're going to add that back. We're going to say ranking coffee methods. Now tables are very specifically formatted elements. Tables have a t-head. T-heads have TRs, which are table rows. And TRs inside of t-heads have what's called a TH, which represents a header cell. So a header cell would be something like way to make the coffee, or we'll just call it coffee maker. Then we'll say ranking. Now let's see what that looks like. Nothing yet, but now we add our table body below our table head. And our table body is going to have table rows, and each table row is going to have table data, which is TD. And those are what populate your columns. So your rows are, your horizontal ones. Your TDs fill the columns. We're going to say Chemex, and we're going to say TD, absolute favorite. And then we're going to say instant coffee, nostalgically like, least favorite, still. Then we're going to say, diner coffee from a drip. Guilty of liking this just as much as an AeroPress. And then, pretend that we fill this out more, AeroPress. And we'll say medium and medium favorite. And now we have this table. It's not a really pretty table, but if you were reading through the HTML, you would totally be able to understand what's going on here just based on the content itself. You'll be able to see, oh, the Chemex is the absolute favorite because they are in the same row being described by this table header. So tabular data is like an information dump. It's just about getting information to you. Now, we're not going to go through grouping a recipe or grouping a news article just because we did coffee instead today. But one of the other most important things that you can do, which you'll need to do for a lab, is referencing something else. Now, I didn't include it with an anchor. Oh, here we go. One of the most important tags you'll use is the anchor tag. Now, you might say, how on earth do I navigate from one page to another? Well, it's a pretty simple thing. It requires two files. So I'm going to do another add. Git add dot is shorthand, by the way, for saying git add everything. I'm going to do git commit -m added table to describing coffee preferences, git push origin feature slash coffee. And then what we're going to do is we're going to add another page. So we'll say chemex.html. And we're going to take all that basic content. Well, in my case, I'm going to copy paste everything. We're going to take all this content and we're going to say Chemex coffee. Or a history of the Chemex. And then we're going to say I have the Chemex coffee maker was invented in, and we're going to do a ... over there because I have absolutely no earthly idea when it was actually invented or by whom. So, but now we're going to see that we have two pages, so we want to start describing our pages with references to every other page. So we're going to use two other elements, a header element, which is different from a heading, which describes that there's data kind of related to your page, your document, in reference to just kind of like metadata almost about your content. Not metadata about your content in the same way that the head element is, but this is where you do things like logos, navigations, and stuff like that. And in here, we're going to make a nav. Nav, coincidentally, is an element that describes navigation from page to page. And we're going to make an unordered list inside of our nav, and we're going to make two list items in it. Well, we're going to just make one list item in it, rather. And we're going to say href equal index.html title equal homepage. Now, here we've created a header, and we're going to use that same header everywhere on our site. Usually we'd have a server figure out how to do that for us. And you'll see here, now we've got this tag here, and this tag points to this file called index.html. Now I'm going to explain a couple things about it in just a moment. Now, I'm going to go to my chemex anchor, my chemex element, and I'm going to add an anchor tag inside of here, and I'm going to have it go to the chemex.html file. We're going to say title about the chemex. Now this just became an anchor. An anchor is something that refers to another page. Basically, that's the most special thing about the original version of HTML was the fact that it was marked up such that you can go from one page to another. Now we're going to click on that anchor, and it's going to take you to this other page. This other page has an anchor that will take you home. Oh yeah, I'm zoomed in over here. That's why the pages look different. I was really confused for a second there. So anchor tags will allow users to navigate, and the way they do that is by having an attribute called href, which is hypertext reference, which refers to another location. Now right now, just by putting index.html, I'm using a form of referencing called relative location. So whatever folder I'm in, it will navigate to index.html in that folder or chemex.html in the same folder. There's two other ways, which we'll learn more about when we do servers themselves, which are called root relative and absolute paths. Absolute paths are when you include a whole URL. That would be like saying http://yahoo.com or google.com. The browser knows, hey, that's an actual full path right there. Don't try and put it on this domain that we're working on or this folder we're working in. Just go to that URL. And you'd use that form of referencing to kind of go through and reference external assets, which we'll go into more with the CSS lectures, or you'd use them mostly for your anchors, which are really the important part of it. So finally, let's talk about one of the most important things you have to do for the sake of getting a good grade. Because while it's nice to make your content all accessible, friendly, and so on and so forth, I'm sure we all think it's very nice to get 100 on our lab as well, which is really why we're going to pay attention in this part. Your HTML is just text. It's not compiled in any way, shape, or form, so it's entirely possible that you're going to write HTML that's not valid. Now, when your HTML is not valid, that means your browser has to guess how to fix it, and it could guess wrong. Now, they're very good at guessing, but you really want to make sure that you don't have invalid HTML, because your browser could guess wrong. It could think that, oh, they forgot to close this tag, this element over here, so now all this content is actually a child of this particular element. And it could just totally change how your layout looks. It could totally change all sorts of things like that. And it makes it harder for assistive technologies to interpret your document. So, the W3 website, now W3 is the organization that pretty much dictates the direction and specs of what HTML is, has an easy-to-use validation service. And I'm going to show you just how easy it is to check. Go to this URL. Make sure that you're at this validate by direct input. And go to your page, click View Page Source, right-click, View Page Source, copy all this, paste it into here, hit that check button. And we're good. We don't have any errors. We don't have any warnings. If you have an HTML error, you will lose points on your labs. You will lose points on your final project. Just no real reason why you would have HTML errors. But say I forgot to include a title. Let's go back to that index.html page, take that source. I get a warning. I don't have a title. Now my anchor tags, if I have an href, it's really bad if they don't have a title because, well, okay, actually that wasn't for the href not having a title. Sorry. Your anchor should have titles. That's what hovers over the. That's what hovers over. They should have titles. But I'm getting a warning because my section doesn't have a heading. Well, that's a good point, actually. So my section really should have some form of heading that kind of describes the way that I make coffee. So here, I might want to put my H1 there, and then in here, it has an H2. So I'm going to take that warning, say, well, that's kind of really sensible, and I'm going to want to change all my H2s over here to be H3s. No, these stay H2s, sorry. I'm going to copy my source again. I'm going to check it. Now my index is pretty good. That caught me. That was a gotcha. I should have known off the top of my head, hey, you're making that main section. Put your H1 inside of there to describe what that section's about. Now warnings, you might lose points, you might not, depending on the type of warning. Some warnings we're really not going to care so much about. I don't have any good examples off the top of my head. But you know, they're very easy to fix. HTML in general is very, very easy to make valid. So try and make sure that make sure rather that your document has no errors and hopefully has no warnings as well when you submit HTML for this course. Run through that. Now finally, kind of not so important, but just so you know, we can denote kind of information about each element, which will come in handy when we start writing CSS in a week or two, by giving them a class or an ID. Now classes describe elements in a way that they can belong to a whole collection of elements that all share a class, whereas IDs are just unique for each element. Can only be unique once per document. So for example, our main tag might have an ID of, there we go, might have an ID of main content, whereas our and every single article might have an ID as well, but we wouldn't be able to reuse that ID, you know, from article 1 and article 2. They would have different IDs, but they might have the same class, like coffee description article. So are there any questions about HTML today? Awesome. So do we understand right now what it kind of means to say we should focus on our content first and why we would want to do that? All right. All right, then I'm going to shut the feed down. I hope this was helpful for the web course. So goodbye, guys. We'll be uploading this shortly.